Welcome back, and thank you for coming back for the lessons again. Now this time we are going to study forces in equilibrium, part 3. There is a reason why I call it part 3. I'll let you know later. Now even as we study forces in equilibrium, just remember that in the study of physics, it is just like a game. And to enjoy the game and to do well in the game, you need to follow the rules. Alright? You want to do well in physics. I would like you to do well in physics too. But to understand physics really well, you cannot just read and read and read. It does not help you that much. What will help you is doing output revision. You need to study the right way, answer the questions, do your rehearsal, draw the diagrams over and over again. That is what will help you eventually. Now at the end of today's lesson, what you should be able to do is this. Number 1, you should be able to draw a triangle of forces in equilibrium. Alright? And you are able to draw this diagram to scale. And from this diagram, you can actually determine the value of the tension in any of the strings. Alright? So let us look at the question now. The question reads, Diagram 3.1 shows a pendulum bob of mass 0.6 kg being hung from the ceiling. Alright, so it's a very straightforward diagram. And the thread is pulled horizontally by a force F so that the thread makes an angle of 30 degrees with the vertical line. Now this is the question. In the space below, draw to scale a triangle of forces to show the 3 forces in equilibrium. Determine the force F. Now if you look at the question, it does not say calculate the force F. So it means that by a scale drawing, if you can get the value of F, I as your teacher, I will mark you correct. And I will give you full marks if you draw it accurately enough and if your answer is close enough to the theoretical answer. Alright, are you ready? Now before I forget, please get ready your protractor, your ruler, your pencil. You will need all these instruments to draw a good diagram to scale. Always have this with you in your bags. A few things to note even as we start out on this question. We are given the mass of the bob as 0.6 kilograms. So I will write it down. Alright. Mass equals to 0.6 kg. Alright. So I would like to know what is its weight. Because if you look at this bob, there is a weight. Alright. Its mass is 0.6 kg. So the weight of it is this. The weight of the bob is mg. Now the mass is 0.6 kg multiplied by g is the acceleration due to gravity, which is 10 meter per second per second. So I would get 6.0 newtons. Now this is very important. You must settle this before you can proceed. So the weight here is equals to 6.0 newtons. Or you can write just 6 newtons is alright. So we proceed. Alright, that was the question. We have already looked at it earlier. Okay, so this is the crux of the problem. Draw to scale a triangle of forces. So the first step is, before you draw to scale, you can have a sketchy diagram, a rough diagram so to speak. Alright, so you will be looking at your original diagram in the question again. So what I'm going to do now is, I'm going to give a rough diagram to you first. Alright, what is the weight? You just sketch it. Alright. Now we sketch the weight. Alright, so the weight is 6 newtons. Now this is a sketch. Remember, I am not drawing to scale yet. Alright, what is F? Alright, so this is F. So this is the tension. I can call it T. What is the angle? 30 degrees. I know what you are trying to say. So, Uncle Pang, your sketch is so neat. It looks like a diagram to scale. No, this is just a sketch, alright? Okay, now, from this diagram, I know where it is leading me. So what I'll do is, I will label it. I can label it X. I can label it Y here. And Z there. Alright, just for the purpose of reference. Okay? So now what I'm going to do is this. Now remember, this is my sketch drawing. Alright? I need to refer to this. Okay, you are jealous of me again because my computer can work magic. Alright? I can change color, don't worry. Yeah, you see? I can change the size. Alright, now so this is my rough diagram. I'm going to take it off once I have given you the actual diagram to scale. So I'm going to use a good scale here. Alright. Now, so I'm going to choose a certain scale. I'm going to choose 2 centimeters. 2 centimeters representing 1 Newton. Alright, so that is my scale. I'll write down this is my scale. 2 centimeters to 1 Newton. Okay. So I'm going to start by drawing XY first. Because that is the line that I know. It's a vertical line, XY. So it is 6 Newtons. That means I need to draw 12 centimeters. Okay. So this is accurate drawing now. Right, you can do the same. Right, 12 centimeters. I've overshot. Use my eraser. Okay, very good. So this is XY. Okay, this is the weight. Alright, it's represented by 12 centimeters. So the second line that I'm going to draw is XZ because I know the angle, 30 degrees. So I'm going to take the protractor from point X, I'm going to measure 30 degrees. Now this is very simple because you don't have to do any calculation. You just draw and draw your way to success. 1, 10, 20, 30. Alright, very good. So I've got 30 degrees. So from X, I will draw a line. Alright, you should be doing the same in your exercise book. Alright, so I mark this 30 degrees. Alright, so over here on my right hand side, okay, on my right hand side here, this is actually my rough drawing. Alright, this is just a sketch. Now my scale drawing is on the left. One more thing now, I'm going to draw the third line. From Y, it has to be 90 degrees. Because F is pulled horizontally, we pulled F horizontally, so it has to be 90 degrees. Measure it as accurately as you can. Alright, okay. So let's say you have drawn a perfect line. Because we are short of time. So this is 90 degrees. So X, Y, Z. So this is actually our force F. Got it? So the scale drawing is on the left hand side. So on the right hand side, it is the sketch drawing. So when you hand it up to the examiner, when you hand it up to your teacher, you need not have this diagram. You can take this diagram off. Alright, because this is just a sketch. Alright. Just give your teacher the accurate drawing. Alright. So now I'm going to measure. I will write down from the diagram or from the drawing. I will have to measure YZ because that is what I want to get. Alright. So I will measure YZ. YZ is equals to 7.0 centimeters. And if I refer to the scale here that I have chosen, you will notice that therefore force F is equal to 3.5 newtons. And if you had followed my program for the part 2, you will realize that the force F from a calculated value, it is 3.46 newtons. So F equals to 3.5 newtons is a very good result here. Alright, let me tidy up the diagram. ZX here, I have the tension. Alright, and this is the weight. I can actually write down the weight equals to 6 newtons. Alright, so what is the final answer? I have already determined the force F or the tension F. It is 3.5 newtons. Alright, so once again, as you look at the aim of our lesson, the objective, now you are able to draw a diagram to scale for 3 forces in equilibrium. And from the diagram, you are able to determine the value in the tension of one of the strings. Alright, so since you can do that, I'm very happy that you have fulfilled the objective. So I'm sure all of you are happy being able to answer a question like this. So with that, I would like to say thank you very much and may God bless you. See you again.